but we can say it equally well that cash balance are 1/6. That is, the people are on the average holding 1/6 of the annual sales volume of the form of cash balances. That from the Cambridge equation, M is equal to KPT. K is equal to M divided by PT is equal to $500 billion divided by $3,000 billion is equal to 1/6. The difference between the two approaches involve more than mere mathematics. Each raises a substantially different set of questions where the money transaction velocity approach the questions where do people spend money. The cash balance approach asks the question why do people hold money. Milton Friedman, a general acknowledged the leading contemporary the quantity theorist, puts this matter this way: the essential feature of money economy is that it enables the act of purchase to be separated from the act of sale. An individual who has something to exchange need not seek out to be double coincidence. Someone who both wants what he has and offers to exchange what he wants, he need only find someone who wants what he has, sell it to him for general purchasing power money, and then find someone who has what he wants but buy it with general purchasing power money. In order for the act of purchase to be separated from the act of sale, there must be something which everybody will accept as general purchasing power, but there must be also be something which can serve as a temporary abode of purchasing power in the interim between sale and purchase. This is the aspect of money emphasized in the cash balance approach. The second significant economic difference between the equation of exchange and the Cambridge equation is that where V is on the left hand side of the former equation, K is on the right hand side of the latter. Mathematically, of course, there is no difference at all. We may put anything anywhere as long as we observe the rules of algebra, but in terms of economic analysis, the Cambridge version of the quantity theory is highly suggestive to a wholly different approach. Take another look at equation 9, which is repeated here for convenience. M is equal to KPT. The left hand side of this equation is open to direct interpretation. It is simply the supply of money, but the right hand side is also readily interpreted. It is the fraction of annual sales volume of the economy which people are holding in the form of cash balances. In other words, it is the demand for money. The Cambridge equation thus has the happy property of casting monetary theory in a mold familiar to all students of economics, supply and demand. To see how the Cambridge equation can be used to analyze the role played by the quantity of money in the economy, let us assume as before that the economy is in equilibrium with M is equal to $500 billion, K is equal to 1.6, PT is equal to $3,000 billion. Then according to the Cambridge equation, $500 billion is equal to 1/6 of $3,000 billion. People are holding just the quantity of each cash balance which they want to hold. The supply of money is equal to the demand for money. Now suppose that for whatever reason the Federal Reserve increases the quantity of money. Change on the right hand side of the equation. To see the answer of this question, note that people now have larger cash balances than they want to hold. They only want to hold 1/6 of PT or as cash balances, but now they have cash balances equal to 1/5 PT. that is K is equal to M by PT. $600 billion divided by $3,000 billion is equal to 1 by 5th. The supply of money that is exceeds the demand for money. People and the business will thereafter attempt to reduce their cash balances. They will do this by buying things, by spending their excess money balances on all the immediate things our economy offers: stocks, bonds, shirts, machines, and so on. But none that while one person can decrease the amount of cash balances he is holding, everyone taken together cannot. The money simply gets passed from hand to hand like the game of hot potato children play. The result is a great churning of expenditures in the economy. These expenditure cause PT to rise. If transaction T are at or near the maximum because of full employment, then most of the rise of in PT will be caused by a rising price level. In other words, in their efforts to reduce their cash balances, people will bid against one another for the things they buy, with the result that prices will be bid up. The classic case of demand pull inflation, where too much money is chasing too few goods. Equilibrium will be restored only when prices have risen sufficiently that PT holds equals $3,600 billion. For when PT equals $3,600 billion, then people will once more be holding 1 by 6 PT in the form of cash balances. That is $600 billion divided by $3,600 billion is equal to 1/6. The supply of money will once more be equal to the demand for money, and the system will be back in equilibrium. The process also works in reverse. If the Federal Reserve should decrease the supply of money from $500 billion to $400 billion, then the public will have less money than it wants to hold. That is, the demand for money will exceed the supply. As a result, people will try increase their cash balances by holding onto their money, but as in the previous case, their efforts will be frustrated in the aggregate. There is only so much money to go around, and not everyone can get more. But in its efforts to increase its cash balances, the public will decrease its expenditures, with the result that prices will fall. Prices will continue to fall until PT drops to $2,400 billion. At that point, K will once again equal 1/6. That is, K is equal to M divided by PT is equal to $400 billion divided by $2,400 billion is equal to 1/6. The economy will then be back in equilibrium with the supply of money equal to demand for money.